Well, in the renal system, the renal system, also called urinary system, have kidney, ureter, bladder, and urethra. We're going to spend a lot of time talking about the kidney. They are the filters. The kidney's location is in your abdominal cavity. They're in the floating ribs area. So if you hit the floating ribs, the last two pairs of the ribs, you also hit the kidney. And in your abdominal cavity, a lot of organs, like those organs for your digestive functions, they are stored in peritoneal cavity. This is a double membrane cavity. But your kidney actually in the posterior, they're outside of peritoneal cavity. And they're very posterior, they're right next to the spine. Because of their structure, so if the surgeon really need to approach kidney, they will actually ask the patient to lie in a prone position, and they will go from the posterior to approach the kidney. They create less damage if you go from the posterior side than from the anterior side. And your kidney, you have outside is the capsule, and it can be divided into the cortex. That's the cortex, and inside is medulla. And medulla have those repetitive triangle structure called renal pyramid. And they form the urine. The urine will be processed by this small tube we can talk about called the nephron. And once it go to the here called the renal sinus. And together it becomes the renal pelvis. And from the renal pelvis, we'll go to the ureter and go to the bladder. So once it go to here, we call the urine. And this the slide show you the kidney structure. So the same, the cortex, the medulla, and this small funnel, I call the minor calyx, I call the small funnel. And the bigger funnel is the major calyx. And the biggest one is renal pelvis. So once it reaches here, we call it urine, and go to the ureter and go to the bladder. And if you have kidney stone, what happens is those razor sharp stone will go through the whole ureter and go to the bladder, and from the bladder through the urethra come out. So you feel like there's a knife inside and cut your body, because kidney is in the abdominal cavity and bladder is in the pelvic cavity. So it will go through the old ureter down, and you feel like there's a knife cut you. Your renal artery send blood to the kidney, and kidney is supposed to clean it. So the renal artery will start to diverge out, and eventually they will go to the nephron and clean those blood, and those clean blood will go back through the renal vein and go back to your circulation. And this slide show you those blood flow. So from aorta, it will branch out and to the descending aorta to the renal artery, and they'll branch out, eventually go to the efferent arteriole, and it will go to the glomerulus, that's the capillary network. And this part will send the blood into the nephron. And it will go through the efferent arteriole and go through the vein system and go back. And this is the nephron. So all this previous slide show you the blood vessel diverge out. Eventually their job is to send the blood into the nephron and being processed. In your kidney you have millions of nephron, and they are called the functional unit. They are like the lobule in the liver. They are the functional unit. So each one of them, they serve exactly the same function as the kidney. That's the definition of functional unit. And this slide show you the nephron. So the blood will send into the nephron, and they will be processed. An important molecule will be taken back, but eventually they will go through the duct, and it go to here, minor calyx. And once it reach here, that's the urine. So your urine directly come from your blood. That's why in the hospital they will take your blood sample. They also take your urine sample, because we know a lot of your body by looking at your urine, because your urine directly come from your blood. This slide looks very complicated because it not just show you your nephron, it also show you your blood vessel. So the blood vessel, you have one capillary called glomerulus in the head of the nephron. Its job is to push the blood, some of them, not all of them, into the tube being processed. And once it's been processed, a lot of important molecules need to be taken back. That's why you need to have a second capillary called peritubular capillary, and especially this part, they're close to the loop, we call them vasa recta, and they take a lot of important molecule back, reabsorption process. So you have two capillary, glomerulus and peritubular capillary. So you have a capillary connect with another capillary, we call the portal system. So that's the third portal system you see in your body. You have the portal system in between your hypothalamus to your pituitary gland. You have another portal system between your small intestines to your liver, and that's the third portal system in your kidney. And that's the nephron structure. So we're going to spend time talk about the nephron. It can be divided into the head part called the renal capsule, also called the Bowman's capsule. And you have the proximal tubule, loop of Henle, distal tubule, and collecting duct. So the blood will be sent in to the Bowman's capsule, being processed, and eventually when they go to here, they become urine. And a lot of important molecules they need to be taken back. So around the tube, we will have the peritubular capillary is being removed, and their job is quickly take the important molecule back to your blood circulation. And in your kidney, you have over 1 million of nephrons. Each one of them serves exactly the same function as a kidney, which is to filter your blood and make your blood clean. So it will be filtered in from the glomerulus, and it moves in through this tube. Once it moves in through this tube, the lumen, we call the lumen, the liquid inside the tube, will be taken back. That's the reabsorption. And once they've been taken back, we consider they are clean blood. And sometimes you can have secretion. If the kidney think this toxic molecule, they want to facilitate the process to get rid of them, they can dump them from the capillary and back into the tube. That's the secretion. And eventually you're going to have, if you have secretion, you actually have more of the molecule in your urine than compared with the filtration part. So these are the process happens in the nephron. And that's the head of the nephron, that's the glomerulus, and that's the Bowman's capsule. And afferent arteriole will keep sending the blood here, and from the hydrostatic pressure will push the blood, especially the plasma part from the glomerulus, go into the Bowman's capsule. So this process is called filtration. And this slide shows you the glomerulus capillary. And glomerulus capillary made of epithelium cells, that's a leaky area. How they decide, okay, the molecule can move in, could not move in, depends on the size. So this layer is the basement membrane, and outside they put the podocyte cells. Podocyte cells is the cell outside of the glomerulus. It creates like the slit. So the smaller molecule can be filtered in, like your water, salt, and glucose can be filtered in. But big molecule like red blood cell, it will stay here. So red blood cell won't show up in your urine unless you damage this. You can damage this by infection, or you damage this by physical force, like people got kidney being punched in the kidney, and this you damage this, red blood cell can move in, and when red blood cell move in, it show up in your urine, and you pee blood, and you freak out because that's not normal. That means your kidney been damaged. So red blood cell usually stay here. And smaller molecule, if they're smaller than this size, they can be filtered in. So water can move in. In your urine, you have a lot of water. The salt can move in. The electrolytes, ions can move in. Glucose actually can move in. But once glucose move in, they will go through the reabsorption process to take all glucose back if you are healthy, because your body needs glucose. And if they could not take all glucose back, and you have glucose show up in your urine, that's That's diabetes. And that's why diabetes patients have to watch the blood sugar, because if you put too much glucose in your sugar, you put too much glucose in the kidney, you increase the workload of the kidney to take glucose back. Eventually it can lead to kidney failure, and they have to use the external machine to replace the kidney's function, and that's dialysis. Okay, let's take a break.